Hello students. So today we discuss in the topic magnetic circuit and transformer. And first we introduce what is the magnet. Magnetic fields are described by drawing flux lines that represent the magnetic field. So basically this is the magnet having N and S pole, and these are present different number of magnetic lines. So when the lines are close together, the flux density is higher. When the lines are further apart, the flux density is lower. So we can see visual in these lines to obtain what is the flux density, maybe less or maybe more. So basically this is the magnet to represent N and S pole and S to N. So basically it is defined by attraction or repulsion. So that is the magnetic flux line are invisible, but the effect can be visualized with the iron filings sprinkle in a magnetic field. So this is the bar magnet like and to establish pole and to S and traveling the magnetic flux lines. Okay, so basically that is the material, it is the waste material, it is the ferromagnetic, it is the basically soft material to easily magnetize. So materials such as iron, nickel and cobalt have randomly oriented magnetic domains which become aligned when placed in a magnetic field. So thus they effectively become magnets. Okay, so first it is the definition of what is the flux density. So the unit of flux density in Weber and unit of flux density Weber per square meter, which is Tesla. So we can obtain this relation B equal to phi upon A. So flux density is given by equation B upon phi A. So these number of flux lines two passing in a per unit area of cross section. So obtain that is the flux density denoted by B. Next definition, how to obtain flux density like is for 8 mm by 10 mm rectangular core and flow or set up the flux in 4 milliweber. So obtain flux density by put this value in this equation. To obtain flux density value, it is the 50 Tesla or 50 Weber per meter square. And if the current carrying conductor to place the magnetic field to traveling the magnetic flux lines, so the field lines are concentrated in figure, and this is the case of bar magnet. The effect of electrical current can be visualized with iron flings around the wire, and that it is to see the effect of the current may be lower or may be higher. To obtain next definition, what is the permeability? So permeability, it is the important terms for find the ability of material, means what is the strength of material. So that is important term to help by obtain BH curve. BH curve basically magnetization, field flux density and field intensity obtained by the permeability of material. So permeability, it is the two category. One is the absolute permeability and another is the relative permeability. Absolute permeability, it is value, it is the fixed, it is the 4.2 10 power minus 7, and relative permeability, it is the variable permeability to obtain the relation from mu upon mu naught. Next definition, what is the reluctance? Reluctance, it is the important term for a magnetic circuit. It is just like it is the reciprocal of resistance in electric circuit. So resistance, it is the opposite of the flow of current. Like for reluctance is opposite to the magnetic flux in the coil. So that is the relation R equal to L upon mu A. R basically this is the denoted by S. So that is the L is the length of the path, mu is the permeability, A is the area of cross section. So we can find the reluctance of the material. Recall the magnetic flux lines around the current carrying wire. A coil reinforces and intensify these flux lines. So the cause of magnetic flux is called the magnetic motive force, which is related to the current and number of turns. So this is the mm equal to N into I representation. N is the number of turns, I is the current. So we can represent magnetomotive force of the magnetic circuit. So just like it is for Ohm's law according of magnetic circuit, phi equal to Fm upon R. Basically that is the like is the current, I equal to V upon R. So similar for Fm is the magnetomotive force upon reluctance. So it is the analogy of electric circuit, like is the current, it is directly related to the flux. MF is analogous to the voltage and reluctance is analogous to the resistance. So we can see compare here electrical and magnetic circuits. So we can, what is the flux if the core is wrapped 300 tons coil with a current is 100 milliampere, if the reluctance of the core like this 1.5 into 10 power 7. So we put the value of this relation to obtain the value of flux. So MF is the N into I. N is the 300, I is the 100, and reluctance, what is the value 1.10 into 7. So we put this value to obtain the value of flux, it is the 2 microweber. And this also another example for find the what is the MMF is true force physical signal find the. So this is the current in the coil of the flux and iron core. What is the MMF? 200 tons coil and 3 ampere current. So the N into I multiply. So we can calculate 750 ampere turns of the magnet. And next definition, magnetic field intensity in the magnetomotive force per unit length of a magnetic path. So H equal to mmf upon length. So mmf denoted by Fm upon L. mmf it is the Ni upon L. So we can find this is the magnetic field intensity H, and magnetic field intensity represent the effort that given current must put into the establish a certain flux density in a material. So this relation to find the permeability of material by with the help of magnetic flux density and intensity of the magnet. So permeability it is equal to B equal mu h, or it is mu equal to B upon h to obtain the relation for a different types of material. So the relation between B and H valid up to the saturation when further increase in H has no effect on the B. At one point it is called the saturation point where there is no effect of the field intensity and flux density will be established. So this is point it is called the saturation point where the no changes after increasing the magnetizing force flux density will be certainly constant. So this is curve plot between the flux density and field intensity. So different types of material we can also draw the hysteresis loop. A small the loop means is the good material, and if the loop increases, so that is the not for good types of materials. So first it is start from the zero origin to establish the current, and this is the point. It is the saturation point obtained. This saturation point where the magnetization it is the full magnetization present, and this is after this no any value increases, so that is the again when change the position of the switch. So this is point it is called the coercive force where the magnetizing force will be zero when the current it is decreases. So then current decreases, the magnetizing force also decreases, but some flux density will present. 2 in the circuit, it's called the retentivity of material. 2 residual magnetism present in that case. Next position, it is the when again increasing value of the magnetization force. So that point it is called the flux density will be zero, but magnetized force in the reverse direction. So that force it is represent the coercive force or coercivity of the material. So this is point. It is the coercivity of material means magnetized force in the negative direction, but flux density will be zero. And again increasing the value of coercive force, or so in the and this point it is called the demagnetization, and it is the material fully desaturate, and this point it is the demagnetization point. Again increasing changing the position of switch and complete the hysteresis loop, and to help to find the permeability of material. Like for example, it is BH curve of magnesium material and yield iron material. So that is the different position of field intensity, and this is the different position of flux density. So if the Like this is the magnet, annealed iron magnet. Current it is the 0.9 ampere and 380 turns, 6.4 centimeter length, and this is the length is 5.1 centimeter. So find the flux density of the core. So that is the relation H equal to Ni upon L. N is the 380, I is the 0.9, L is the 0.23 meter. So we can obtain the field intensity 1.1487 ampere turn per meter, and this value lies between this point 4 after 4 100 400 value like more than 1400. So this is the point, it is obtained value, it is the 1.63 Tesla. And this magnet is basically based on the Faraday law of electromagnetic induction. So Faraday law, it is defined like this is the magnet, and this magnet it is having number of turns. So by according to Faraday law of experiment with generating current by relative motion between magnet and the coil of the conductor, so the amount of voltage or EMF induced across the coil by two factor means two law. One is the rate of change of magnetic flux with respect to the coil, and another is the number of turns of the conductor in the coil. So these relation we can find just moving magnetic field induces a voltage, current in a coil causes a magnetic field. So the coil acts as the electromagnet with travel from north to s pole as it is called permanent magnet. These are the basic definition of the magnetic field, magnetic flux, permeability, reluctance, and these are the unit representation. Magnetic flux density in Tesla, flux it is the Weber, permeability Weber per ampere turn per meter, L is the reluctance denoted ampere turns, uh, ampere turns per meter, and magnetization force and magnetization force, or sorry, magnetomotive force. So magnetomotive force, it is causing a magnetic field in measure in the unit terms, like is the ampere turns. This is solenoid, it is electromagnetically controlled device, which is they have mechanical movement of the shaft by the magnetizing current. Hysteresis, this is the very helpful to find the permeability of material by hysteresis loop. And retentivity, it is the point where the some magnetism present in the magnet, but force will be zero because the current it decreases to the zero position. So that is the point called the retentivity of material. Induced voltage is the changes of the magnetic lines in the magnet. Faraday law is a law stating that the voltage induced across a coil of wire equal to the number of turns in the coil of times coil times the rate of change of the magnetic flux. And what is the Lenz law? Law states that when the current through a coil changes, the polarity of the induced voltage creating by the changing magnetic field in opposes the changes in the current of the current cannot change instantaneously.